So, welcome to another Level 3 Probability Concepts video. This is the third part of Venn diagrams, and this is lesson 3b, follows on from 3a. Now, in 3a, we talked about mutually exclusive events which cannot both occur at the same time. In a Venn diagram, if there's more than one event, the circles don't overlap, and so the probability of A intersect B is 0. Now, events that are not mutually exclusive events can both occur at the same time. In a Venn diagram, if there's more than one event, the circles do overlap. So the probability of A intersection B is greater than 0, but obviously less than 1 because probability can't be greater than 1. All right, so in our two-way table, this box here of intersect A and B is a number that's not 0. Now let's move on to the probability of A union B, or we say A or B. And this is a formula you need to know about. This is the probability of A plus the probability of B, subtract the probability of A intersect B. Let's explain what's going on. This is the probability of A, this entire circle on the Venn diagram, and we're going to add on the probability of B, this entire circle on the Venn diagram. But notice when we add on A plus B, we end up adding the cent bit twice. And that's why we have this little subtract at the end. We subtract P, A intersect B, because we don't want to add that cent bit twice. Right, I'll explain it a bit more detail with an example. In a standard pack of 52 cards, the events of drawing a spade and drawing a 7 are not mutually exclusive events. Right, here's our Venn diagram, So we have the S represents getting a spade and the 7 represents getting a 7. And here's our two-way table happening at the same time. Now we can get an intersection between them because that just means getting a spade and a 7 at the same time, which is the 7 of spades. And there's one chance out of 52 that this could happen. Now this box, or this part of our Venn diagram, is getting a spade, which is not a 7. And there are 12 other cards we could pick, so 12 out of 52. This section is getting a 7 but not a spade, so there are 3 other 7s we could pick, 3 out of 52. And this is the section where it's not a 7 and not a spade. Not a 7, not a spade, and you could count them up. There are 36 out of 52 cards left. Right, well, let's check our total. Our columns and rows all add up to 1. Remember, 52 out of 52 adds up to 1 whole, which is what we need. And let's answer a couple of quick questions. Here's the first one. P bracket S intersects 7. The probability of a spade and a 7, well, that's just getting the 7 of spades, which is 1 chance out of 52. But what about P bracket S union 7, or we say probability of spade or 7? And here's the formula we're going to use. The probability of spade plus the probability of 7 minus that extra bit of probability of spade intersects 7. So the probability of getting a spade, there's 13 chances out of 52, 13 spades out of 52. And the probability of getting a 7, there's 4 7s out of 52. But we've ended up doubling up on one of those. We have to subtract 1 out of 52 to get our final answer of 16 out of 52. Now, see if I can explain that with a diagram. Here we go. Here's our pack of cards. So we have 13 chances out of 52 of drawing a spade. There's 13 spades. And we're plussing on the 4 chances out of 52. There's 4 7s. But have you seen in the process in doing that, we've ended up adding the 7 of spades twice. We've only got 13 spades and 4 7s, but one of the 7s is a 7 of spades. So that's why we take away the 1 out of 52 to get us down to 16 out of 52. So the probability of getting a spade or a 7 is 16 chances out of 52. There's 16 cards that are either spades or 7s. Right, thanks so much for watching.